you check it yourself. So thus the solution of this equation is mt. You check it, this is at plus I. So at least for lambda is equal to mu, then m prime t is equal to a, which is constant. That means mt is equal to your at plus c. So now m of 0 is equal to I. So from there, whatever you have, that c is equal to I. And hence I have at plus I if lambda is equal to mu. Okay. So if lambda is not equal to mu, then whatever you have to do it, you just looking at the integrating factor, or you can think of multiplied by e to the power minus lambda minus mu times t, and then you write down in an exact kind of form and then integrate. So from there, whatever you have, that this is a by lambda minus mu e to the power lambda minus mu t minus 1 plus I e to the power lambda minus mu of t, for lambda is not equal to mu. So just note that this I is not the complex number. It's not that the root of minus 1. This I is basically if initially you have ith number of population or ith number of people, or the population size is I initially. Okay, so that I. So mt is basically given by at plus mu. If lambda and mu are same, so then actually the expected or the mean population size is depending on this is linear, proportional to your immigration. Okay, so now here actually you see that as mt converges to infinity, okay, if my that means as t goes to infinity, mt converges to infinity. So for two cases, one thing is that if your lambda is greater equal to mu, okay, so from that means if lambda not equal to mu here, so for lambda is equal to mu, we have at plus I, that again converges to infinity because a is positive. And from here also you see that this is something, but you have exponential growth, so that converges to infinity. Okay, so that is I'm saying that it is expected. No, if uh, the birth rate is high compared to the death rate, and again you have the immigration, so again people are coming and they are also giving the birth. No, so that is the expected that the mean number of population or the population size it is going high, means converges to infinity. And what happen if lambda is less than mu? So in that case you see that mt this is converges to, in this case what I have from here, this is a by, because this one, okay, lambda by mu. Sorry, this is lambda minus mu, then it's be mu minus lambda, because minus thing, this goes to 0, this one is goes to 0, so only this minus 1 factor is coming, so a by mu minus lambda. Okay, this is that is the naturally you can expect that the only thing is that if your death rate is high compared to your birth rate, but still as t large enough, the mean population size would be a by mu minus lambda, because you have the immigration, is it not? So the a is the rate of immigration you can think of. So I have a by mu minus lambda, which is kind of the constant. Okay. Okay. So now I'll talk about a particular process, that is again a birth and death process, that is called the pure birth process. Pure birth process means basically, so I'm saying that pure birth, then there is no death. That means mu n is equal to 0 for all n. Okay, only birth is possible in some cases. So as a definition, I say that a birth and death process is said to be pure birth process if mu n is equal to 0 for all n. Okay, so it's not this mu n, it is basically your mu n is nothing but that q I minus 1. Is it not? Also q n minus 1. That is actually equal to 0. There is no bar. So simplest example for the pure birth process is basically the Poisson process. Okay. Poisson process, actually you will see Poisson process where lambda n is equal to lambda. Okay, this is the constant birth rate. For n is greater or equal to 0, there is no birth, no death, mu n. Okay. So for the pure birth process, again we will talk about again the special process. So when so this is constant. Now I'm talking about the linear case. Okay. So example. Now suppose my xt, which represents the population size at time t. So in each member in the population which act independently and gives birth at an exponential rate lambda. Okay. So each member of the population acts independently and gives birth at an exponential rate, say lambda. Okay. So now as I said that suppose no one ever dies, that means it is a pure birth process. Suppose no one ever die, then this xt is a pure birth process. Okay. With lambda n, this should be n times lambda for n greater or equal to 0. So this birth process is called the Euler process. This process is known as Euler process. That means it is a pure birth process which is linear, n times lambda. Okay. So now I time to find out what will be the distributions of the Euler process. Okay. So now suppose the Euler process starting with a single individual at time t is equal to 0, means x of 0 which is equal to 1. Okay. So I talk about the distribution of Euler process. What I'm saying, so initially at x0 is equal to 1. Okay, that means only single individual at time t is there. Okay, and x0 is a Euler process. So I denote my ti for I greater equal to 1. This is the time, okay, between the I minus 1 and I birth. Okay, so this is the time taken or the time between I minus 1 and ith birth. That means that population between I to I plus 1. So whenever it's I minus 1 birth is happening, that means total number of population should be I. and then I birth is happening, total population should be I plus 1. So Ti is nothing but it is the time for the population from I to I plus 1. Ti is the time it takes from the population size to go from I to I plus 1. Okay, because it is the time between I minus 1 bar and ith bar. So that means it is the in terms of number of population. So the population size, it will go from I to I plus 1. That is the time taken for that I denote as a T of I. Okay. So now Ti is, as we said, that it should be independent and exponential distributed with lambda I lambda. Okay. And exponentially distributed with rate I lambda. So now we is to find the distributions of ST, XT, which is the number of population at time T. Okay. So now check it. What is my the T1 less than equal to T? This is nothing but it is T1, which is independent and exponentially distributed with rate lambda. So this is nothing but 1 minus with bar lambda T. Is it not? 1 minus with bar minus lambda T. Okay. So now what is the probability of T1 plus T2 less than equal to T? This actually I can write down. Okay, we'll see that why I am just writing down the time taken and all these things. So T1 plus T2, this is less than equal to T. These things actually I can think of. This is nothing but I can take the conditions on my T1 and then I have that part. So probability of T1 plus T2 less equal to T, this actually I can think of this is 0 to T, probability of T1 plus T2 less equal to T given T1 is equal to X and then the d of dt on X. So from here whatever I have, this is lambda d bar minus lambda X of dx. Is it not? Just using the total probability law. Conditions with your T1 is equal to X, that means X should be going from 0 to T and then I have this part. So now if you just calculate, so what I have, because T1 is equal to X and then you know the distributions for your T2. So from there what you have, this is 0 to 2 and then whatever I have, this is 1 minus, because T1 is equal to X, T1 is equal to X, so Tt is equal to T minus X and then T2 is equal to 2 minus X, then what I have, this should be 1 minus e to the power minus 2 lambda of T minus X, is it not? Because Ti, this is independent and exponentially distributed with rate I lambda. So T2, this is 2 of lambda and since T is there, so whatever I have T minus X times lambda times to the power minus lambda X of dx. Okay. Now if you calculate this one, that you end up with 1 minus to the power minus lambda T times square. Okay, so now we see that probability of T1 less equal to T is equal to this part, T1 plus T2 less than equal to T is this square. Okay, so you can expect that maybe if I consider T1 plus T2 plus T3 less than equal to T, then it should be 1 minus e to the power minus lambda T times whole to the power Q. Okay, let's see, and then you can write down by induction. Okay, because you now have some kind of pattern for that. Okay, so you can use the induction to write down that part. Just see the some for the few cases. So whatever probability of T1 plus T2 plus T3 is less than equal to T. So these things again I can write down. I can consider now probability of T1 plus T2 less equal to T. So I know that what will be the corresponding distributions for that, because this is the distributions of this. So what I can write down, I can consider that the conditions on t1 plus t2 is equal to x. Okay, and from there actually I can have. So these things, as I said, that I need to consider the conditional with respect to t1 plus t2. So this is probability of t1 plus t2 plus t3 less than equal to t, given t1 plus t2 is equal to x, and then that the df of corresponding this t1 plus t2 is equal to x. So what it should be, because you need to the differentiate, this is 2 times. So I have then 2 into lambda e to the power minus lambda x into 1 minus e to the power minus lambda x of dx. Is it not? Just using the my previous one, and then I am using the total probability law. So I am having this part. Again, you try to use t1 plus t2 is equal to x, and then again t3, that is again I will look at the ti's which are independent exponential distributed with rate I lambda. So from there what you have, this is 0 to t, now 1 minus e to the power, now I have minus 3 lambda, then I have whatever I have t minus x, is it not? T minus x, and then whatever I have 2 lambda e to the power minus lambda x, 1 minus to the minus lambda x over d of x. Okay, now if you do the calculations for this case, okay, you check yourself, but it will end up with e to the power minus lambda t to q. Okay, thing which exponential things is there, we know how to integrate it, so directly you can integrate it. Okay, so that means, as I said, that just looking at this pattern and so on, basically one needs to use the induction, so one can check. So by induction argument, we can easily check that. So now if I consider that's over any j, so probability of summation over I is equal to 1 to j of my ti, okay, if this part is less than or equal to t,